The Kap Shui Mun Bridge is one of the two major bridges forming the Lantau Link, an essential link in the expressway and airport railway connection between Hong Kong Island and the new airport at Chek Lap Kok. The bridge has a main span of 430 meters and crosses the channel called Kap Shui Mun between Lantau and Ma Wan Islands. It is connected to the Kap Shui Mun Bridge by a 503-meter-long Ma Wan viaduct. The bridge has been designed to carry two 3-lane carriageways on the upper deck and two railway tracks below, with two sheltered, single-lane carriageways to be used during high winds and emergencies, like the Kap Shui Mun Bridge. But unlike the Kap Shui Mun suspension bridge, the Kap Shui Mun Bridge is a cable-stayed bridge. The bridge is supported by 176 cable stays, and each is made up of numerous high-tensile steel strands. Each stay is erected as soon as the corresponding main span unit has been lifted. The deck units and the cable stays are assembled and extended from the towers towards the middle. A cable-stayed bridge does not require deep anchorages or erection of suspension cables. It is faster and cheaper to build. Because of stability problems, this method is generally used for bridges less than 1,000 meters in the main span. The foundation work for the Kap Shui Mun Bridge started in mid-1993. Besides the main span, a cable-stayed bridge needs heavy side spans to anchor the cables. Groundwork included the two towers on Lantau and Ma Wan, as well as piers for these side spans. The two towers are founded on bedrock. The Lantau Tower is in shallow water, protected by rock armoring against collision with ships. On Ma Wan, the tower has been built on a ledge cut into the steeply sloping rocky edge of the island. Because the Ma Wan Tower is built on sloping rock, one of its corners has to be supported by hand-dug caissons, like the piers on Ma Wan Island. The tower tops are 150 meters above water level. The tower legs were constructed by the jump form process, in which the concrete shutters move up as a complete unit every 3 meters. The tower legs are joined together by post-tension struts. The tops of the towers are post-stressed to control the bursting forces of the stay cable anchorages. The construction of side spans and the towers started in mid-1994 and took about a year to complete. The Ma Wan side span, the Lantau side span, and the Lantau approach span were constructed by the incremental launching technique. This employed specialized shuttering for the casting and a sliding system to move the finish units forward. Casting yards were set up, one to the west of Lantau approach span and one at the east end of the Ma Wan side span. The spans were divided into approximately 18 meters long units, cast one at a time. After the first unit was cast, it was connected to a launching nose and moved forward towards the towers by 18 meters. The next unit was then cast behind it and joined to it. These two units together with the launching nose were then moved forward and a third length added. This process was repeated until the first unit had just passed through the tower legs. The launching nose was later converted into the first main span unit. In parallel with the construction of the towers, the approach span and the side spans, assembly of the main span started. The Kap Shui Mun Bridge decks were partly steel and partly concrete. The sloping webs and connecting frames were steel, but the top and bottom decks were concrete. An economical solution for this 430-meter main span. Partially fabricated steel sections, delivered from the contractor's yard in Shekou, were assembled at the assembly yard beside the barge dock built on Lantau, close to the Lantau Tower. 8.4-meter long main span units, with steel webs and concrete decks top and bottom, were built progressively in 5 assembly bays either side of the barge dock. As each unit was finished, it was slid onto the barge at low tide. When the tide rose, the barge was towed to position under the main span, and the unit was lifted by special cranes onto the part-completed bridge and joined to its predecessor. The first lifted unit was joined to the launching nose. The steel webs of the units were joined by bolting. The concrete decks by casting a 1-meter infill length. For each unit, a stay cable on each side of the bridge was installed and stressed before the next unit was brought from the dock for erection. For each main span stay cable installed, a corresponding side span stay cable was fixed. The side spans were also anchored to their supporting piers by holding down cables to prevent uplift under full main span loading. There are 176 cable stays, and each is made up from between 51 and 102 high-tensile steel strands according to location. The strands are formed from 15.7 mm diameter galvanized wire, greased and protected by plastic sheathing. They were laid out on the bridge and cut into the right lengths. Each strand was erected separately by light electric winch, and the completed stay was stressed as one to a load of between 500 and 800 tons by a special jack as soon as the corresponding main span unit had been erected. Each stay is further protected by a heavy-duty plastic sheathing. The anchorages, one at deck level and one at tower top for each strand, incorporate wedge blocks grouted with an epoxy sand mixture. The construction of the Kap Shui Mun Bridge remained well on schedule, the main span being finished by mid-1996 and the surfacing and finishes by spring 1997. By this time, the Ma Wan viaduct connecting the Kap Shui Mun Bridge and the Ching Ma Bridge was also completed. Trains to the airport will pass over the bridge and through the viaduct at speeds of up to 135 kilometers per hour. A special sound deadening and resilience system of concrete slabs beams and elastomeric bearings is used to support the continuous rails. On the 22nd of May 1997, the Lantau link, consisting of the Kap Shui Mun Bridge Ma Wan viaduct and the Ching Ma Bridge, was opened to traffic linking New Chep Kok Airport with the rest of Hong Kong.